some of the module objectives that we're going to cover are first to define and describe a network and a computer network. You've heard the term network before, and so I want to define what that is and how that relates to a computer network. Next, I want to describe the components of a network, what makes a computer network. I want to define the terms node and server, which will be helpful going forward when we use those terms. Define and describe the network backbone and the various variations of a network backbone. And finally, I want to define the difference between a terminal, a client, and a peer. All right, so let's get started. Now, because networking is ubiquitous, we need to define a few specific things in order to keep things in order. So first, network. This is an interconnected or interrelated chain, group, or system, generally based on a purpose. So for instance, if we say that you're going to Facebook or LinkedIn are social networks, because the purpose is to be social and to connect with other people who have similar interests, likes, etc. In the same way, you are interrelated and you form a group. Now, based on that, a computer network is the interconnecting of two or more computers that have a basic core purpose of communicating electronically. So, the network of social network is to communicate with individuals about a specific topic. On a computer network, we need to communicate data electronically. And that's the thing that joins us together. The internet is one really large computer network. And we will see how that comes to play later on in this course. Now, whether your network is comprised of 2 computers or 2,000 computers or, like the internet, 2 million computers, there are some commonalities in networks and requirements for what makes them. The first thing that are needed, obviously, are devices. These are the actual computers, the printers, the switches, the routers, all of the devices that are going to be connected together by media. Now, media can either be a physical connection, such as copper, or newer forms such as fiber optics, or it can be something wireless, like Wi-Fi, or radio frequency, or even cellular Wi-Fi. Each device, however, has its own language when networking, and not every device knows how to communicate with the language of these other devices, right? Because obviously a computer communicates slightly differently than a printer, slightly differently than a router, etc. So in order to allow all these devices to communicate with the rest of the network, we have something called a network adapter, sometimes referred to as a network interface controller or a NIC, specifically in the term of computers. And it serves this network adapter as a translator between the components, the devices, over the media by which the data is sent. So finally, to manage and govern how everything talks with everything else, the network needs an operating system, which is similar to like the ringleader in a circus, if we can use a metaphor there. It tells the network how to work together in order to perform as efficiently as possible over the adapter, over the media, and with each of the devices. Without the operating system, there wouldn't be any order or direction in the network, and no one would really know what they were doing. So the network operating system is responsible really for allocating resources, monitoring the activities of devices on the network over the media, and managing files and data, etc. Now, we have 2 devices that I want to define. One is a node, and a node is any device that is connected to a communications network. And this can be just about anything. So we have clients and servers are nodes, and so are printers and network-attached storage devices. And these are all what we call endpoint nodes. I'm going to write that up here, because that's where the data ends. Whereas something like a router or a switch, or previously, we used to see a lot of hubs, do what's called redistribute. So those are what we call redistribution nodes, okay? So it's important to understand that these are both nodes. Anything on the network, really, any sort of device that's communicating is a node, or being communicated with. The endpoint nodes where the information sort of ends up or is going to. A redistribution node, its responsibility is to pass the data on to another either redistribution node or onto the endpoint node. Now, a server is a network device that's responsible for sharing resources and managing certain services, like addressing. And we'll talk about this, which is called an IP address, a little later. It also manages devices on the network and controls the network-wide functions like permissions. So not only is it going to give all our clients, all the other nodes, addresses that allow it to communicate, it's also going to manage how those devices communicate and what they're allowed to do, which is what we call permissions. All right. Now, this is, so you can see that the server is a type of node, but I just want to describe server. We're going to talk about some of the other devices in just a moment. Before we do that, let's talk about the network backbone, okay? The network backbone is responsible for carrying the majority of network traffic, and it works very quickly at a very, very, very high speed. Now, it might use different technology throughout this on the backbone that's different from the rest of the network because it basically connects all the smaller networks together. That's why it's called the backbone. And it needs to be large, fast, and capable of communicating at very high speeds because all of these computers, all these smaller networks are communicating. We'll talk about how that all works in a bit. Now, there are 4 different types of network backbones, and I'm just going to give you a brief definition of these now, and we will come back and talk about these more in depth a little later, okay? The first one is called serial. That's where one backbone cable connects to another, one after the other. Like so. All right? So there's one backbone cable, and multiple switches are connected to that cable, which allow devices to connect to it. There's also something called a hierarchical or distributed backbone, which, like a family tree, it has more of a family tree layout, if you can imagine, right? Okay, and this backbone is, in this case, it's much easier to manage, typical for what we'll call local area networks or LANs. It's much more easily scalable, as you can see, because I can update one part a lot faster. And in this case, the backbone is responsible for the traffic of the nodes on each branch. So we have different branches, and on each branch, the backbone is responsible for that, and that's how it gets a little easier. Now, a collapsed backbone uses a router as the connecting point. All right, and we'll talk more about how that works a little bit later and what exactly a router does and how that's different from a switch. And that's a pretty major point. Finally, we see something called parallel, which is just like a collapsed backbone, except it has multiple cable connections, and that's because that allows for more redundancy. Remember, if you took the A+ class, we talked about redundancy and how we want to make sure that we don't have what are called single points of failures. So there's more than one cable connection, which not only is great for redundancy, it also allows for what we call load balancing and also a faster throughput because the computer can decide which of the cable connections to use. All right. So these are, again, we have serial, hierarchical or distributed, collapsed, and parallel. As we talk more about networks, these differences will become clearer. But I just wanted to cover them now. And you won't probably see these specifically on the exam in this format. You'll see them in other formats. But I want to lay the framework for what we're going to be talking about. All right. Now, a terminal. A terminal is a network hardware device that's used for entering data into it and displaying data from another computer or computing system. It's commonly called a dummy computer because it doesn't have any processing capabilities of its own. It also doesn't have much memory or anything else, okay? So it is literally, this is a dummy. It's basically a screen with a keyboard, a mouse, some sort of input tool, right? And what it's doing is simply displaying information on a bigger, better server computer someplace else. All right? We also need something called a terminal emulator placed onto this computer so that it can emulate what's going on the server and communicate with it, since it doesn't have processing capabilities or memory of its own. Now, this is different from what's called a client. A client has its own processor and memory of its own, but it accesses network resources on other nodes, other servers, and other clients. All right, so it is, rather than a server which serves up information, the client takes the information and uses it. Now, a peer is a network computer that provides its own resources and services and computes on its own. The best thing about a peer is that it can act, it is self-managed, self-contained, and it is both a server and a client. Okay? So you can see how this works. This peer computer serves information to this peer computer as a client. This computer can serve information to this one as a client. So this is what we call peer-to-peer networking. It manages its own set of local policies. It has its own set of users. It is completely self-contained and does not need a server to operate, unlike a client, which does. All right. So, just to recap what we've talked about, we defined what a network is and how that's different slightly from a computer network, which is really what the Network Plus exam covers. We described the components of the network, the adapter, the network operating system, the devices, the media. Let's go ahead and write those. We had media, right, which allowed the devices to communicate using a network adapter. Communicated and managed by an operating system. We also defined a node and server, right? The node is really any sort of device that's on, we have the endpoint. And we also have a redistribution. We defined and described the network backbone, remember, which is really fast. And the different variations of it, which, if you recall, included serial, which is one after the other, hierarchical, also called distributed, then we looked at collapsed, and a more redundant form called parallel. Finally, we defined terminal, client, and a peer. Remember, the terminal is a dummy. Client accesses resources on other computers. And a peer both serves and accesses. All right. So now that we've covered some of this basic terminology, let's continue on talking about the fundamentals of a network and discussing more of what we need to know in order to get into the majority of this information on the Network Plus exam.